In this video, we'll explore the world of temporal databases. Temporal databases are designed to manage data that changes over time within database systems. Let's dive in to understand how these databases handle past, present, and future information. Temporal databases are database systems that store and manage time-varying data. They maintain a history of information as it changes over time, rather than just storing the current state. A regular database only tracks the current state of the data, like an employee's current salary. A temporal database, on the other hand, tracks all historical states, such as an employee's salary from a start date to an end date. Temporal databases use different time dimensions to track data changes. We'll discuss 3 key dimensions. First, valid time represents when a fact is true in the real world, such as when an employee's salary is actually in effect. Second, transaction time represents when data was actually stored in the database, like when a system audit trail was recorded. Finally, bitemporal databases combine both valid time and transaction time to provide complete temporal tracking of the data, offering a full history of changes. Let's look at an example of valid time. Consider tracking employee salary history. In the table, you can see each employee's salary with a valid from and a valid to date. For example, Alice had a salary of $60,000 from January 15, 2020 to March 31, 2021. Then her salary increased to $65,000 from April 1, 2021 to June 30, 2022. Finally, her salary became $72,000 from July 1, 2022, and is valid to the end date of the maximum date available. Valid time captures when facts were true in the real world, allowing us to see Alice's complete salary history. Now let's explore transaction time with a database system audit trail example. The table displays when employee department information was entered or modified. For Carlos, his department was initially recorded as engineering on January 10, 2022, at 9:15:22 seconds. This record was valid until March 15, 2022, at 14:30:45 seconds, when it was updated to marketing. Diana's department was initially recorded and then corrected within 5 minutes on February 5, 2022. Transaction time records when data was actually stored in the database, capturing each change as it occurred in the system. Let's see how valid and transaction time work together in a bitemporal example, tracking employee salaries. On March 10, 2022, Human Resources recorded that employee 301 will receive a salary increase from $70,000 to $75,000, effective July 1, 2022. The first row shows the original entry that was later updated. The second and third rows show the corrected information with the planned salary change. Bitemporal databases allow you to track both when facts were true in the real world and when they were recorded in the database, providing a comprehensive temporal history. Temporal databases require specialized query languages to effectively retrieve time-based data. Here are some examples. First, an AS of query retrieves data as it was at a specific point in time. This example finds employee salaries as of January 15, 2022. Second, a between query retrieves data within a specific time range. This example finds employees who worked in marketing at any point during 2022. Third, an overlaps query finds data where time periods overlap. This example finds employees whose employment period overlapped with a project timeline. Finally, a transaction time query retrieves data as it was recorded in the database at a specific time. This example finds what the database recorded about employee 301 as of March 1, 2022. There are several ways to implement temporal databases. One approach is native support, which involves using database systems with built-in temporal features, such as SQL 2011 Standard Temporal Extensions, Oracle Workspace Manager, SQL Server Temporal Tables, and PostgreSQL Temporal Extensions. Another approach is implementing temporal logic in the application code itself, using custom object relational mapping extensions, temporal middleware, Hibernate envars for auditing, and version control patterns. A third approach is to use specialized systems designed specifically for temporal data management, like TimeDB, Temporal DB, time series databases, and event sourcing architectures. Temporal databases have numerous key applications. These include financial systems and regulatory compliance, healthcare records and patient history, version control and document management, auditing and data forensics, and business intelligence and trend analysis. However, there are also challenges. These include increased storage requirements and complexity, query performance optimization, schema design and normalization challenges, security and access control across time, and application integration and user interface representation. Temporal databases offer robust capabilities for managing time-varying data, which allows organizations to maintain historical accuracy and support time-based analytics. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.